so next up, it says if a trig expression has the form of a sum or difference identity, so that like expanded form, you can use the identity to go backwards. So simplify the expression to the trig function of a single angle. Okay, and if that single angle is one of the reference angles that you know, or one of the angles from the unit circle that you know, then you can give the exact answer. Okay, so here we're in an expanded version in example 3. So I have both the sine and cosine identities here, so we can compare and see which one it matches. Okay, so I would say we've got cosine of u, because both of them start out with u. So we're starting out with cosine of u. So we've got double cosine. So remember, double cosine, cosine u, and then cosine v. That's a different number. And then sine u, and then sine v. Okay, so this one is cosine for sure. Now, is it the sum or difference? So remember, it's the opposite. So this one says that it is minus, okay, right here. So remember, when you condense it, it's the reverse of that. So it's going to become plus, okay? And again, the 25 is the u and the 15 is the v. So when we condense this, it'll be cosine, and u is 25, the opposite is plus, and then v is 15. Then you can actually do that addition or subtraction. So this is 40. Now, if you knew cosine of 40, you give your answer. We don't. We're not using calculators. We're just simplifying. Let's say it had come out to 45, then yeah, I could go ahead and tell you cosine of 45 is root 2 over 2. But I don't know cosine of 40. I'm just simplifying. That's my answer. So this is cosine of 40. And if the question said, what identity are you using here? Remember, this is the cosine sum ID because you added in the condensed version. All right, in this one, same idea. Okay, cosine and sine are mixed together. Sine and cosine, cosine and sine. This one's definitely the sum or difference ID for sine. Now, the sum or difference stays the same in sine, so we know it's going to be the difference. Okay, and then we are going to identify. So 42 is the first term we're seeing, so that's my u. And then 12 is the orange. And 12 is the second term I'm seeing. That's going to be my v. Okay, so when I condense this, I'm using sine of u minus v. This is the sine difference ID. Okay, so it becomes sine of 42 minus 12. Sine of 42 minus 12 is sine of 30. That's one on the unit circle we do know. We know sine at 30 degrees is 1/2. Okay, later. Go close the door. Sorry, that's my son. Okay, so next up, we can use these ideas to simplify expression and verify equations. So it's back to being given in the condensed version, but notice one of them is a variable. Okay, so we're not going to have a final answer because part of it's a variable. So we're just going to be simplifying. Okay, so I'm going to expand here. X is now my u value. 3 pi halves is my v value. And it starts out in the condensed version as the difference. This is the cosine difference identity, but we know when we expand it, it's the opposite of what we had here. Okay, so this is going to become cosine of x times cosine of 3 pi halves plus sine of x times sine of 3 pi halves. Now again, know your unit circle. Cosine and sine at 3 pi halves. If you need to jot stuff down, jot stuff down. 3 pi halves, that's right here. That ordered pair is over 0 down 1. So remember, that's your cosine, that's your sine. Okay, you don't have to sketch this if you know your unit circle or have your unit circle out when you're looking at it. But cosine of x is now being multiplied by 0. Sine of x is now being multiplied by -1. Well, anything times 0 is 0. And sine of x times negative just becomes negative sine of x. So the 0 does not need to be written. We simplified this to negative sine of x. All right, and then here in 6, let's try a tangent one. You're not going to see tangent as often, but let's give one a shot so you've seen it before. Okay, so this is our u, and this is our v is 3 pi. That's going to get plugged in everywhere we see v. And then we are going to add. So remember, the top stays the same. The bottom is the opposite. Okay? So remember, again, if you're not understanding what we're doing here, verify. That's what we were doing in 5.2. We're proving one side equal to the other. So we're working this left side. It's the more complicated side. We're trying to prove that it does indeed simplify the tangent of x. Okay, so when I expand this, I'm going to have tangent of x, that's my u, keep the same sign, so plus, and then tangent of 3 pi all over, and then 1, and then the opposite sign, so minus tangent of x, tangent of 3 pi. All right, so again, you can sketch the angle if you need to. You don't have to. We know a full circle is 2 pi, half a circle is pi, so 3 pi puts me here. You know the ordered pair is -1, 0, and you know tangent is sine divided by cosine, or y divided by x. With 0 divided by anything, hey, it's 0. The tangent at 3 pi, that's 0. So in my numerator, that becomes 0, and in my denominator, it becomes 0. Forgot to do my highlighting for y'all. I'll go back and do that real quick if it's helpful to some of you. So that's how we knew what signs we had. Our x was our u, and our 3 pi was our v. All right, so when you're adding 0, you don't need to write that. So my numerator is just tangent of x. Now anything times 0 is 0. So that's gone. It's 0. 1 minus 0 is just 1. Anything over 1 is just itself. So this is just tangent of x, which is what we're trying to prove. So we've now proved it.